Sometimes people write to me because they are stuck in a CTF challenge and they hope I can help them. In this case, it's a person who is apparently trying to exploit a format string vulnerability. There's always a bit of a conflict for me because I want to help people, but it takes a lot of time to do so. You will see how much time it costs even with a simple challenge like here. And to be honest, I'd rather invest this time into making videos for thousands of people than helping one individual person. No offense. But when this person wrote me, I just happened to stand at the platform waiting for my train and had nothing better to do. And actually, in the end, helping this person exploiting this vulnerability, but turning that into a video to showcase their mistakes and sharing my thought processes, it becomes a very valuable learning resource for a wider audience. By the way, voice actor helping me for this episode is none other than John Hammond. So let's head into the DMs.
I'm trying a CTF and I need your help. It's about print string vulnerables and stack bleeding. I managed to leak everything but the flag. Here's the server and port to connect with Netcat.
They also share a screenshot. They called it a print string vulnerability. But given the description and the screenshot, I think it's more commonly known as a format string vulnerability. If you don't know what a format string vulnerability is, please watch my old binary exploitation episodes about it. Anyway, as I said, I was outside on my phone, so I couldn't check the challenge with Netcat myself. So my first response was, what's the question? Because I'm already annoyed that this person didn't share important details. Please watch my videos raging about that before you send me questions, because this text and screenshot contains so little information that I have to guess a lot. And my guesses could be wrong. That would help nobody and would be very frustrating for all sides. Though this person got lucky, it is such a simple challenge that I was pretty confident that I knew what was going on. But just to make sure and teach people to ask proper questions, I'd rather poke back and ask, what's the question? I mean, there was no question. The person just stated that they leaked everything but the flag. I know it's a format string vulnerability. Apparently, we have to leak the stack to get the flag. And in between the task description, I see leaked environment variables, home, path, pwd, and some more. This makes sense because environment variables are stored on the stack at the beginning of the stack. So apparently this person already was successfully exploiting the format string vulnerability and leaked stack variables, but they didn't leak the flag. The question for me now is, how was this output generated? There are two possibilities. This could be a script decoding output and make it printable text, or the person used %s in the format string exploit to leak strings. That's why I asked about more details. I don't want to guess what you did. Show me what you did. And so they sent me their script.
Here's my Python code. What am I doing wrong? I connect to the challenge server and then iterate over a few offsets and send a format string input with %s to it. I can't seem to get the flag.
Based on this code and the screenshot, I was actually 100% sure about what was going on. So let me explain what I was thinking. Let's start with a recap how format modifiers %s works compared to, for example, %d or %x. When you write code like printf %x value, then the compiled assembly code will place the value on the stack as a literal value. There are some 32-bit and 64-bit differences. 64-bit calling convention passes early parameters via registers, but doesn't matter. Later values are taken from the stack. Thus %x or %d literally print the value found on the stack or registers. But %s is different. Print %s string expects a pointer to an array of characters. And so printf takes the value on the stack as an address, goes to that address, and prints the characters there. Which totally makes sense seeing this screenshot, because there are pointers to those environment variables on the stack. The reason why is not surprising. The third parameter of main in a C program is a pointer to an array of environment variables. So the code that sets up your program and calls main will place pointers to those strings on the stack. So going back to the script, if you now use %s to print different strings from the stack, this is done here with the $ iterating over different stack offsets. Eventually, you might reach such an environment pointer, so printf follows it and prints the string, which explains the evidence I'm seeing. But keep in mind, I'm only confident in my guesses because this is a very simple challenge that I've done many times. A little bit more complex challenge and I would have no clue what is going on. Anyway, If you have a bit of experience with format string exploits, you might even already identify their mistakes. Instead of using %s to leak strings, you should use something like %x to literally leak the values on the stack. You will leak them as hex values, and so you have to decode them first, but you leak the actual values on the stack. Anyway, now that I know the most likely solution, I could just tell them. But I don't like to do that, especially when I don't know if this is some kind of active CTF. I am not your CTF cheat code. I want people to learn, so I like to have a back and forth conversation. And that's why helping people costs time. So I ask, where's the flag? Because even though my solution idea might work, maybe the task of the challenge is completely different. Maybe you need to get remote code execution. Again, not enough information given. But they respond with
flag curly braces.
To which I respond, not what is the flag, where's the flag? What's the goal? Do you have the binary or is it blind exploitation? Is the flag in memory somewhere or do you need remote code execution?
Here's the post. It's the only info I've been given.
Stack bleeding. This program will echo anything you write. Can you exploit this? Okay, stack bleeding sounds like the flag should be on the stack. Now we can actually go into the technical details. I respond that I have an idea to try, because now I think I know their problem, but first I have another question. What exactly does %s do? I ask this question because I want them to carefully think about what they do so they can figure out their own mistake. Basically, I look for an answer what I just explained, that %s takes a pointer from the stack and prints the string at the target location. It doesn't print the actual value on the stack. But I get the response.
Just halts it. If I remember correctly, it doesn't echo.
I mean, your exploit uses %s. So what do you try to do with it? What does that format string do?
So if I go up the stack using something like %2 $s, if it has a string, it echoes it. If not, it seems to halt or it doesn't echo.
Can you describe to me how $2 $s prints a string? I know the question might be a bit confusing. I try to get to a specific detail and difference between %s and, for example, %x. Why does %s not work sometime? Why does it break? And why does $2 $s not break? You can see me here hinting again at what I want. I directly ask what the difference is. I want them to tell me that %s follows a pointer on the stack. So if a value on the stack is not a valid address, then printf will fail, it will break. But %x would not fail because it literally prints that value. But it didn't work yet.
So basically, %offset I $s tells it where on the stack to try and put a string from. The author told me to bleed the stack, so I think it's a play on words. Why %s breaks it sometimes, I have no idea.
Did you watch my videos about format strings? I know, it's a bit unfair to say that. Nobody watches all my videos, but those are all topics that I've covered. At least I think so. And so sometimes it makes me a bit sad when I get questions that would be answered if they would remember everything I said in videos. I know it's a bit unfair, but anyway. Next, I try to ask the same thing in a slightly different way because I'm trying to figure out how to ask so their brain responds to it properly and realizes their mistake. Does %s print strings from the stack? This is a bit of a trick question because the answer is kind of yes or no, depending on how you interpret it, but I was thinking about it this way. %s follows pointers on the stack and prints strings where they point to. So those strings could be anywhere in memory. They don't have to be on the stack. If you realize this, you would figure out your mistake.
I did, but there's a few.
So I guess they did watch my videos. I also just checked my script in episode hex 1e. I briefly mentioned it there. Also, because we already know it would be about a format string vulnerability, we can try to inject some characters such as %x, but again, nothing happens. We could also try %s because if you remember, it will take values on the stack as the address location of a string. Thus, if values on the stack do not point into valid memory, the program should crash, which would be another indication of a format string vulnerability. But no, also doesn't do anything. But I understand there's so much information in so many videos, you might not remember that, and I guess I wasn't super clear either. So, alright. But there are also tons of other format string exploit tutorials online, and literally the first result when searching for format string exploit what does %s do writes this. The printf in the second line will interpret the %s in the input string as a reference to a string pointer, so it will try to interpret every %s as a pointer to a string, starting from the location of the buffer, probably on the stack. At some point it will get to an invalid address, and attempting to access it will cause the program to crash. You can see, you can help yourself a lot if you Google around, and so I was hoping this person would explore my questions further, even if it means that they need to research more. And this screenshot shows that %s seems to crash the process, which makes sense. Probably the first address on the stack, or in the first register, is an invalid address. Okay, clearly the person doesn't catch what I tried to get at. So let me try to ask differently again, and this time start even earlier with basics. Okay, let me ask differently. What are strings? What is a string in C?
A character array.
Cool, okay. So let's say you have the char array AAA, BB, ZZ, DDD on the stack, and you print first %s and second $2$s. What do you think it will print? Just try to have an educated guess. Again, this is a bit of a trick question because both answers are it will crash. But I deliberately asked this in this way because I figured they would say the first one prints maybe AA and the second one BB, which would show me they have a wrong understanding of %s. But their answer surprised me.
First one would do nothing. Second one would print that string because %2 is its address.
Ah, okay. I mean, that was completely wrong, but you said something important. 1 and 2 would break because %s looks for an address. %s takes the address and prints the string at that location. %s would try to interpret AAA as an address, and $2$ would interpret BBB as an address, on 32-bit at least.
Interesting.
So how would you print the actual value on the stack and not interpret that value as an address to a char array?
So what can we do if it thinks they're addresses if they're strings? I can get the address with %x.
Oh, we are getting there slowly. I think they almost got it. Now I want to try to check their understanding with another question. Let's do the same example. AA, BB, CC, DD is on the stack. What would it print? First, %x, second, $2$x.
First one prints the address. Second one prints the address's contents?
Crap, that is completely wrong. I think you misunderstood what $2 does.
I thought that meant where on the stack.
Yes, exactly. So why do you say that 2 prints the address content? Why does 1 and 2 do something different? I mean, you just said it says where on the stack it prints the value. So it sounds to me like 1 and 2 do the same, except they differ where on the stack. They don't differ with what they will print. Print the value.
Because 1 is just the first thing on the stack printf gets, and 2 is where.
No, that's wrong, and that's not what you said yourself. But then I stare at it again, and I realized that there's a miscommunication happening. No, yes, it's correct what you say. I see the confusion about the word where. They thought I focus on here is only %x, and here is the dollar offset notation. So they thought I was asking about the meaning of the dollar. But no, I just wanted to know what the expected printf with these conditions is. So I clarify. %x prints the first value in the stack, and dollar decides where. So $2$x is the second value on the stack. Maybe it's the third, I don't know how to count, but that's not important right now.
Yes, but it's %x in hex, and we need a string.
I think they understand now the problem, but they still have some confusion left. They think their goal is to leak the flag. The flag is a string, so it must be %s, because %x would be hex values. So now I try to show them that it doesn't matter how it's represented. What is hex for 1 as a string?
AAAA.
So you can easily convert hex to string. Why do you care that it's hex and not a string?
It should tell us the string in hex.
Why? Why do you care if printf converts the bytes to readable text for you, or if you take the hex and convert it yourself? It's all about leaking values from memory, and that seems to be the goal here.
Because %x is hex. So we convert to string from hex.
At this moment I thought, why are you repeating the same thing? Didn't we just realize that it doesn't matter if you leak hex values or strings? So I got a bit grumpy. Why do you care? Look, when AABBBCC is a string on the stack, then you can't leak it with %s. I explained why. But you can use %x. As you can see, I'm basically just stating the solution now. The output will be in hex, but if you do that, the leaked hex bytes are still part of that string. So why do you care that the leak is in hex? The values you leaked are from a string. Now you just have to convert them back.
I don't care if it's hex, you said so above. And I was replying to that, and it went down from there.
Ugh. Oops, okay, miscommunication again. I thought they still want to use %x because they want a string, but they were just stating a fact. My bad. That's the issue with messages. Sometimes context is lost, and so I got a bit impatient. Whatever, it's forgotten, let's move on. Okay, so what's the problem now?
I have to test it.
I'm waiting. 5 minutes later, I get this screenshot.
Kind of seems like just addresses.
I think around this time I was also back at home, so I didn't immediately respond. 15 minutes later, they added,
Yeah, so far, as I keep going up, I'm not seeing anything that looks like text when I put it into the hex editor.
It's sometimes not easy to recognize a flag in hex output. So I thought I suggest them to convert the expected solution string flag to hex, because then they have the hex values they need to look out for and might be able to quickly identify it. Thus, I asked them, can you convert flag to hex? But in the meantime, I was also back at the PC and I could now check those bytes myself. Of course, I have to type them and can't copy them because it's a screenshot. But I immediately saw some bytes that looked like text. Check out my A Look for Patterns video if you want to know how I knew that. Anyway, those first bytes translate to EHTSSAP, and that is printable text. And maybe it could be the string the pass. The byte order, so the endianness, is effed up, so when we fix the 4-byte endianness, you can see it too. By the way, I'm using the CyberChef tool for this. In an exploit, you would of course write that stuff in Python code, but it's great for playing around with data like here. But it looks like flag does not appear in it, the password and so forth. So maybe that was their issue. Maybe they saw this, but not the flag. And at this point, I also thought maybe it's not the whole leak. Sometimes in format string vulnerabilities, when they appear in a combination with a buffer overflow, you might leak the string itself because your format input overwrites the whole stack, rather than leaking the original bytes you want. And I noticed here those bytes at the end are basically %x. So I thought this is what might have happened here. Maybe it's not the complete leak. The solution to that is not to have a long %x string like here, but have short format strings, and use the dollar offset to leak individual values. And so I said, I see a problem. What do you get when you convert those hex values? What kind of string snippets do you see? At this moment, I wanted them to recognize that they did leak some actual text, but also there is some issue with the buffer. But look at the screenshot they sent.
Went from offset 1 to offset 100, and I didn't see anything hex that really looked like a string.
But that output makes no sense. You saw me just converting some values. But the difference between this and that is that they said they ran the script again to iterate through the offsets. So these bytes are not the ones from here, but from them running their script. So of course, I wanted to see that actual script output. Can you show me the output? The screenshot only shows %x.
Sure.
And now the screenshot shows all offsets by hand in one input. God damn it, that's not what I meant. If there is really that issue with the buffer overflow destroying the stuff on the stack, then this doesn't help. We need the output from the script that does it in a loop with the short format strings. So I responded. A few mistakes you make here. Why don't you use the program you showed me? Change the S to a X. And now they deliver the output of that script.
Okay, the issue with it seems that it skips numbers. Beside the hex number is the I number in the for loop.
And that screenshot is indeed weird. Why are there only a few outputs? I'm getting confused too. So now I need more info. Can you show me more? Maybe copy it to pastebin or a secret GitHub gist or something? I get this pastebin with the output, and indeed, some outputs are missing, which is really weird. But some hex snippets still look like printable strings. So I ask, and have you looked at some of the output there? Any printable string snippets? To which they respond with this screenshot, and yeah, this looks kinda good. At least the initial the in the wrong endianness is there. Doesn't this sound interesting?
Sounds interesting, I guess.
Come on, you're basically there. Please walk the last steps now. The is over. I mean, it sounds to me like it's part of the solution. I could imagine that the complete string would be something like the flag is flag curly braces. So as you can see, I was still expecting to see the flag string to appear in the output, and it wasn't there, which meant we have some other bugs. Maybe the reason for that is that the script itself is buggy. So I wrote. Now we need to just figure out why some outputs are buggy.
It is. Need to fix the Python script first to make it a bit easier.
So I kept thinking about this bug, and I needed a bit more experiments to drill down on the potential issue. First of all, I want to know if the issue only happens when the script executes or if it also happens by hand. Does it always fail to print those? Apparently offset 8 didn't work, so now I'm specifically asking, can you do by hand %8$x?
Something like that. I think the issue is the remote server expects input to give a broken pipe. I mean, second input, like a space. Like, you have to put in what you want it to echo, then hit enter, then enter again to exit. And I think that's why my script fails.
Because I didn't do the test and sent me the results, I thought, God damn it, I do it myself then. So in the meantime, I just tried by hand to print the 8th offset, and it worked. I can print it, no problem. So something might be broken with your script or so.
I think the second part is the server is waiting for another enter and the script isn't giving it.
Yeah, don't know. Those explanations sound a bit weird to me, but I also thought that it doesn't matter because you can also now solve it by hand. If the script fails, you just do the %x by hand. Please just solve it now so we are done with this. But I couldn't help myself, so I did look at the script again and thought about it. And then I realized what an issue might be. Maybe you try to receive too fast. The server is not fast enough with responding. Try to add a time sleep 0.5. 20 minutes later, no response. So any result?
6 to 20, I get this. If I clean it, I get this, which is that.
And they even sent a screenshot along. And look at that. This is readable text. You just have to fix the byte order, the endianness. So I give some hints. Well, you are getting close. Can you fix the endianness? EHT should obviously be the.
I thought it was endianness when I saw it because it was backwards.
Very good. You know about endianness. Glad I don't need to explain that. So fix that. And then they sent this.
Sat for move I is word past the. I'll try again.
Yes, please.
Yeah, I don't know, but the flag has always been flag curly braces. So I don't think that's it.
Sure, but it doesn't matter. You're clearly leaking something that seems important for the challenge. So I ignored this and mentioned again, you are dealing with the endianness wrong. And now they fixed it.
The password is I love format bugs.
Some code they probably used to swap endianness, very good. And then they write,
anyway, thanks for the help. I hope I won't need it again, but I doubt it.
But I wasn't sure if they solved it now. So I asked, is the flag I love format bugs? Did that work? After spending so much time on this, I need the satisfaction of having it solved now.
It did, but every time I've done it before, it had flag curly braces. I don't know where it was in that one.
Okay, well, it's solved. Maybe not the best challenge design when the flag always appeared before, but whatever. They solved it. Congratulations. By the way, maybe you noticed this. I only noticed it when making this video. They actually had the solution already at this point, which was about 15 minutes after we started writing. I was just too lazy to type the bytes, and apparently they were too. So as you can see, really trying to help people takes time. We started talking around 12 and it was solved around 3 p.m. I plotted all the messages on a timeline here just so you can see and visualize how much back and forth this is. It's just messages, but you can't do anything productive in parallel. Constantly you get distracted from those messages. So this was me spending like 2 hours or more on this, and in the end I only helped one person. I hope you understand why I don't have the time for everybody and why I generally prefer to spend those 2 hours working on videos for all instead. But then there was this idea to turn this conversation into a video, and now hopefully you learned something too. Which leads me to the following question. In my imagination, a video like this here is a really good learning resource because troubleshooting and working through issues is the best way to learn. Much better than just me telling you how something works. So please let me know if this kind of video style is actually engaging or if it's boring. And if you want to see more videos like this, or rather not.